All right, today we're going to work on solving equations with variables on both sides. Now, what does that mean? Well, it's going to look kind of like a multi-step equation, but you are actually going to see variables on both sides of the equal sign, so on the left-hand side and the right-hand side now. Now, how does that change everything? Well, there's only a couple changes that really need to be addressed. First off, we're still going to simplify like we normally would. But here's where the difference happens. Right after we simplify, the next thing I would highly recommend to you is get the variables to the same side of the equation. So what that means is we want to either add or subtract to move them over so that all of my variables are on one side. And then we would collect those like terms on that side. So either add or subtract, we're using that inverse operation to move it from one side to the other. Then what we're going to do is we're going to draw the upside down T, and we're going to use our inverse operations to move anything that does not have a variable attached to it to the other side of the equation. Then we're going to simply continue to use those inverse operations to isolate the variable. We want to get that variable completely by itself. Now, one of the major changes to this is what kind of solutions or answers we could get. Okay, so whenever we see variables on both sides of an equation, then what that means is we could get one of any of these three special solutions. Okay, so let's talk about what those solutions are. The first solution is the one that we've been getting for everything so far, back when we solved one-step, two-step, multi-step. It's the exact same. So you work it all the way down, you get x equals some number. What that means is that is the one and only number that would make that original equation true always. Okay, so what we call that is a one solution answer. But you're not going to write one solution on that case. You're just going to leave your answer like you have been, x equals a number or a number equals x. Okay, now the two really special ones, the two different ones that are new now, are what is called a no solution answer and an infinitely many solution answer. The no solution answer, what will happen with that situation is the variables will cancel each other out, and you will be left with a false statement, meaning it'll say something like 5 equals -2. Notice there's no x's involved anywhere. The x's eliminated each other. So when you add or subtract your x's to both sides, they crossed each other out. They took away everything. So then you would be left with an example like 5 equals -2, which is a false statement, and that would mean it's a no solution answer. So what does a no solution answer mean? Well, what it means is that there is no number, fraction, decimal, integer, anything. There is no number that if I were to plug back into the original equation would make that equation true. It will always make it false. Okay? So there's no possible way to get a true answer there. Now, the second other special one is infinitely many solutions. Now, infinitely many solutions, just like with no solution, the variables will cancel out, but you will be left with the identity, which is exactly the same thing on both sides of the equal sign, or you will be left with a true statement. Now, what does that look like? So your x is canceled out, and you're left with something like -8 equals -8. That means that would be an infinitely many solution answer. Now, what does that really technically mean? What it means mathematically is no matter what I plug into the original equation, it will always make that equation true. Okay, so let's give this a shot then. So what we're going to do is we're going to start off here on number 1. And hopefully the first thing we recognize is I have variables on both sides. I don't have anything that I can simplify. So then what I simply do is I look at this and I say, okay, how would I want to get my x's to the same side? Well, a lot of people like to just move them over to the left, which is fine. So if we do that, I would look over on the right-hand side. It's a -2x. So to undo that, I would add 2x to both sides. And that would cancel on the right. Negative 5x plus 2x gives me a negative 3x plus 21, and that equals 6. Well, now anything without a variable, I want to the other side. I see a plus 21, so I'm going to subtract 21. And that would leave me with negative 3x equals negative 15. Then at that point, I would divide by negative 3, and I would get x equals 5. Then, to check that, what you would simply do is you would just plug that in. Negative 5 times 5 plus 21, and you're asking yourself, does that equal 6 minus 2 times 5? Well, negative 5 times 5 is negative 25, plus 21, that would get me negative 4. And the question is, does that equal? Well, 2 times 5 is 10, so 6 minus 10, that's a negative 4, which means that that works. Now, that's how you would check it if you would like to do that. You always have that option to check. You just simply plug back into the x's, make sure your two sides are equal, and that tells you that you're doing those problems correctly. Okay, let's continue on. Let's look at number 2 here. So the first thing I notice is I have 4x on one side, I have 5x on the other. So I'm going to start to solve that. There's nothing that can be simplified. So I can sit here and I say, okay, I see it's a positive 5x, so I'm just going to minus 5x from both sides. 4x minus 5x is a negative x plus 3, and that equals 10. Then I have negative x plus 3, so to undo that, I'm going to subtract 3 from both sides. That would leave me with negative x equals 7. Then at that point, I'm going to divide by a negative 1, and I would get x equals negative 7. Okay, once again, if we wanted to, we could check it. So both of those, numbers 1 and 2, both are an example of a one-solution problem. Okay, because they both worked out to an x equals a number. Okay, on number 3, the first thing you should recognize is you have some simplifying to do. So we have the distributive property here on the left. So the first thing I'm going to do is I'm going to take 5 times 2x, that's 10x. Then I'm going to go 5 times 4, that's 20, and that equals 8x minus 6. My next step now is hopefully you recognize that, hey, I've got 8x on one side, I've got 10x on the other. We've got to get those to be the same on the same side, so I'm going to minus 8x from both sides. 10x minus 8x is 2x plus 20 equals negative 6. Then at that point, I'm going to minus 20 from both sides because that is the least connected to that variable. Negative 6 minus 20 is negative 26. Then at that point, I'm going to divide by 2, and I would get x equals negative 13. And there is that solution. Okay, let's continue on with that same kind of idea here. So we're going to start in on number 4. Hopefully you recognize right away we've got this distributing on one side. So the first thing I'm going to do is I'm just going to write down the left-hand side equals 5 times x is 5x. 5 times 1 is 5. Now at this point, we should hopefully see that we have negative 5x on one side, 5x on the other. So I'm going to get those to be the same. Now, just so you can see that you can do it the other way, if I look at the left-hand side, it's a minus 5x, so I'm going to add 5x to both sides. Now, that gets rid of that on the left-hand side, and that would give me an 8. 5x plus 5x is 10x plus 5. Then at this point, we would subtract our 5, and 8 minus 5 is 3, and that is equal to 10x. Then at that point, we would divide by 10. Now, here's where this is kind of nice. If I wanted to, I can leave it as a fractional answer in simplest form, which would be 3/10. Or I can divide that by 3, take 3 divided by 10, and that would equal 0.3. So either answer there is an acceptable answer. Once again, hopefully you notice that questions 3 and 4 are both one solution answers. Okay? So that is the answer that typically you're going to get most of the time. But here we're going to take a look at the two special cases. So if you notice here on the left, number 5, the first thing you notice is we have this distributing. So what I'm going to do is I'm going to take and I'm going to go 2 times x. I'm going to go 2 times -3. And then I'm going to bring down my right-hand side. The next thing I notice is I have 2x on one side and I have 2x on the other side. So my next thing I need to do is I need to get those to be on the same side. So I am going to minus 2x. Now, here's where this changes. So 2x minus 2x, those are gone. So I get -6. Over on this side, 2x minus 2x, those are gone. So I get a 5. Now, if you notice, that is a false answer. So therefore, what we would write is this is a no solution answer, meaning there is no number that if we plug back into the original equation would make that true. Okay, so let's take a look at number 6 now. So the first thing we recognize is we need to distribute off to the right. So I'm going to copy down my left-hand side. I'm going to take the 5 and bring that down. Then I'm going to distribute. So 3 times x gives me 3x. 3 times 1 gives me 3. Now, hopefully you recognize that, wait a minute, I can actually combine some like terms over there as well. So I'm going to go 3x plus 8 equals, and then I'm going to bring down that 3x. And then 5 plus 3, that gives me 8. Now I should recognize that, hey, I've got 3x on one side, 3x on the other. So I'm going to minus 3x from both sides. And that gets rid of that, and I am left with 8 equals 8. Now, that is a true answer. So what we would write is that is infinitely many solutions. Meaning no matter what number I plug into that original equation, it will always make it true. Okay, so now we can also do this into word problems. So I have a word problem here about a car washing company. So you're signing up for a car wash service. You have 2 options. Car wash company A charges $15 initial fee and $7 per wash. Car wash company B charges $35 initial fee and $3 per wash. So we set those 2 equations up. And it says how many car washes until the 2 companies will cost the same. Okay, so I'm going to make them equal. So it's going to be $15 initial plus 7x, equaling $35 initial plus 3x. Here, the x would represent the number of car washes. Okay, so we start to solve. The first thing hopefully we recognize is that we have this variable on one side, variable on the other. So I'm going to start off and I'm going to say, okay, I'm going to minus 3x from both sides. That gets me 15 plus 4x equals 35. My next step then is I'm now going to minus my 15 from both sides. So I get 4x is equal to 20. At that point, I'm going to divide by 4, and I end up with x equals 5. So it will take 5 car washes to be equal. Okay, so it'll take 5 car washes to be equal. Now, once you get past 5 or less than 5, one of those is going to be cheaper than the other. All right, and that's how we solve equations with variables on both sides.